think it's something to do with movement.
Yeah, it has something to do with motion.
I think yeah, motion, movement. Let me get the proper definition. Yeah, kinetic energy is the energy of an object has due to its motion.
Okay, energy of an object due to its motion. So do you know the formula for kinetic energy?
EK is equal to half mv squared.
Okay, that's good. So for now, like they're asking us that the man and a lift takes a man to a sky bridge which is 100 meters above the ground. So let's just highlight that unit, that that value. It's 100 meters above the ground as shown below, and he makes a huge bungee jump from the bridge.
Yeah.
So they also say ignore air resistance. So they say the man and his gear has the mass of 72 kilograms. Calculate the gravitational potential energy of the man just before he jumps the sky bridge. So, do you know the formula for gravitational potential energy?
Yeah, EP is equal to mgh.
So with that being said, can you give me the answer? I'm just gonna like write it down on the side.
Okay.
Also, so we can do it simultaneously. Uh,
EP equals I don't have a calculator. Let me just my phone. I got an answer of I don't think this answer is right though.
doesn't sound right. What's the answer that you got?
I got 70,000. Wait, 70,000.
Go on.
560.
And what's the unit?
Excuse me?
Sorry?
I said my answer was 70,560.
Yeah, but it also has units because you can't just state the magnitude without the units.
As I say, is it no meters per second? Oh, joules.
Yeah, it's in joules.
Joules, yeah.
So it's gonna be something like, sorry, but like I'm gonna use my laptop mouse, so this might look terrible.
That's
So
cool.
it's gonna be something like E is equal to. So what's the value for gravitational acceleration that you guys use?
9.8.
9.8.
Yeah.
Okay, so it's gonna be 72 kilograms into 9.8 into 100 meters. So you're gonna have 70,560 joules. So now they say state the law of conservation of mechanical energy.
Um,
It's actually not that hard, man. Like you don't need to like go through a book
um,
because every law of conservation, you just know that that particular thing is conserved in an isolated system or closed system, you know.
uh, yeah.
So do you know the equation for conservation of mechanical energy?
Is it EP plus EK?
Yes, go on.
Yeah,
For
and
for
then
for the law, and not only for like not only the equation for mechanical energy, but the full equation for the law of mechanical energy.
it's
Conservation,
gonna be
sorry.
MGH plus of mass with mv squared plus that
Okay.
em equals to mgh plus of mv squared.
I'm just gonna write it like this. E mech initial. I'm just gonna say EM just to save space now.
Mm.
So mechanical energy initial is equal to the mechanical energy final. So do you know this equation?
Not this one you're doing now, but
Sorry.
I don't know the specific one that you're doing now, but I do know the equation for mechanical energy.
Yeah, because you see, let me just get another color here. Maybe let's do it in black. You see, mechanical energy, right? It's
Mm.
gonna be equal to EP plus EK. Am I right?
Mm.
Then it's all about like expanding the equation, you know,
Yeah.
because EP and EK, let me just get a different color here. Uh, Purple. Because EP, it's gonna be our MGH.
Yeah, and then EK is gonna be off mv squared.
Exactly.
Okay, I see.
So when it comes to the law of conservation of mechanical energy, they say mechanical energy is conserved in an isolated system.
Mm.
So that means the initial mechanical energy is going to be equal to the final mechanical energy.
Oh.
So let me just
Is that why you say? Is that why you say EMI or
initial is
mechanical
gonna be equal
initial?
to EM final.
I know. Okay. I see.
So now you can just expand these two equations. Let me just get something, maybe a highlighter. You can just expand these equations
Mm.
into this and finally into this equation, you know. So
Mm.
it's mostly gonna depend on the values that you're given.
Yeah.
In some questions, they might give you the mass and give you the velocity. So you're gonna have to use so you're gonna have to use this equation below.
Mm.
But in some situations, they might just give you potential energy and they won't give you the kinetic energy. So if they give you potential energy only and not the kinetic energy, that means you're gonna use the potential energy. But when it comes to kinetic energy, you're gonna use this equation. You can see that.
Yeah.
But anyway, let's just get into 5.4. Let me just erase these real quick. So
So the law of conservation of mechanical energy is the
the mechanical energy in an isolated, let's just say closed system is conserved.
is where a
You know,
closed system is conserved.
yeah, because like even here they state that ignore the effects of air resistance.
Mm.
So from that, you know that the system is closed.
Oh.
Yeah, because like there's no external forces interrupting.
Okay.
Yeah. So let's go to 5.4, where they say use the law of in question 5.3 to calculate the velocity of the man at height of 50 meters above the ground. So since now you know the law of mechanical energy, can you use it and find the answer for me? I'm just gonna like keep it here so that you know how to use it.
Okay.
Initial is gonna be equal to um, final.
Mm.
If you want me to expand it further, you can just ask me to.
That's cool. Mm. So when they say this, like ignore the air resistance, does that mean that the velocity of this thing is zero? One.
The velocity when like because like here we're gonna have two velocities, the initial one and the final velocity. So
Mm.
yeah, let me just place it like this. Like you can see the details of the bridge and the equation at the same time. So which velocity are we talking about?
Like yeah, by question 5.4, are we gonna use the we're gonna use the mechanical formula.
Yeah,
So we're
that's
gonna say EP plus EK, then I expand in more, I said MGH plus half MV squared.
yes,
So now
because
I have to mm?
because like the initial state of the man, you know, the initial state he's 100 meters above the ground. He's not
Mm.
moving at that time until he jumps. So his initial velocity is also gonna be zero.
Mm. Okay. No, but then I'm gonna use the 50 for the height now. I'm gonna have to use 50 now because they tell me that the velocity.
For the thing is, for which height? Because we need the initial and the final, you know.
Wait, I'm a bit confused now.
Okay, like from this, let's just say the first thing we do, we have to note all the initial conditions, right?
Yeah.
So all the initial conditions, we're gonna use them here, right? So we're gonna have our mass doesn't change. So there's no need for us to write like the initial and final mass. So
Okay.
the gravitational acceleration is also gonna stay the same. So there's no need for me to write it down also. But what we know is that our height and velocity do change, you know. So we're gonna have our initial height, which is 100 meters.
Yeah.
Then we also have our initial velocity, which is 0 meters per second. Right? Okay, just tell me if you get lost. So now in
So before
5.4,
writing all the variables down,
sorry?
you're first gonna write all the variables down, then you're gonna use the formula. Because I don't know what formula to use for this. I know
Oh,
what formula, but I just it's looking a bit because the formula using here EM initial
is equal to
equals
EM
EM
final.
final. Yeah, like how do I punch in the variables into that equation?
That's why that's why I'm like I'm gonna expand it for you just because like
Okay.
so let me just so now the man like in 5.3 they tell us the man is 50 meters above the ground. So the man is 50 meters above the ground. So his new height, his final height in this situation,
It's 50
yeah, it's gonna be 50.
meters.
It's 50 meters. Then the final velocity, that's the one we must find. Okay. So let me just should I can I erase it because like there's no space to write on the question paper. Let me just zoom
Yeah, you
in a
can
bit.
erase.
Okay. So let me just erase this. So from this equation, we can expand it. Just the initial mechanical energy. We know that's gonna be let me zoom in a bit for it's gonna be mgh initial plus 1/2 mv squared initial. You understand it?
Yeah.
because this is the kinetic energy and this is the potential energy. Then this, let me just get a different color, whichever works. This is gonna change into mg h final plus over 2 mv squared final. So do you see it now?
Yeah.
Then all you have to do is substitute in the initial and final values.
Okay. I'm gonna try and do it.
Okay. Zero.
So they must equal to each other.
Yeah, they're equal to each other. That's how you know that energy has been conserved.
Okay, this is how my thing looks like. So I said, my first bracket 72,
Okay.
second bracket 9,8,
Yes.
third one 100 plus a half, and then 72, and then 0 squared for
Okay.
my first. That's for my first initial EM. Then for my final, I said 72 again in the first one. I said 9,8 in the second bracket, and then 50 for the height.
Yes. Yes, that's nice.
Okay, then I said plus half, and then 72 again, and then v squared outside my bracket, because we want to try and find that, isn't it?
Okay. That's nice. So
So
like
that's
the
half.
other thing, I don't think like it's not necessary for you to write this down
Mm-hmm.
because we already found our answer from this one. You see?
Oh, the joules.
Yeah, so we already got our initial potential energy. Sorry,
Mm-hmm.
I have flu.
School.
So our initial potential energy, we already got our answer it's gonna be
70,560.
560 joules.
So I can just substitute that in already.
Yeah, because like we already got it.
Okay, okay. I was gonna do it afterwards. Like,
just to save you some time.
yeah, but I understand.
Yeah. Then from everything we know, any number multiplied by 0
0.
is 0. So here also, like, but you have to show your substitution.
Yeah.
You have to put this one in brackets and show your substitution for all of the for this one.
Then sure I got 0.
Yeah, so I'm just gonna put 0 here. So this is gonna be 0 joules. Oh, so apparently our meeting is gonna end in like 10 minutes. I'm pretty sure you saw that, right?
No, actually on the calculator on my phone, I can't see it right now.
Yeah, so our meeting is gonna end in 10 minutes. So I'm just gonna like start a new meeting, or maybe like 10 minutes is gonna be it's gonna be 8 minutes to 10. So I'm just gonna start a new meeting, then we can finish maybe 5.5.
Yeah.
So here we
Then for
know.
my
Sorry.
second one, my final, I got an answer of 35,280.
This one. Yeah.
Then I say plus
35,000.
of, I have to say off of.
Yeah, because like
So
this one, it's actually half of this one.
off of 72.
Yeah, but half of the 70,000, because 50 is half of 100.
And
So,
okay, okay. I see. Is that where
yeah.
the
So here it's gonna be 72 multiplied by half, which is gonna give
which is
us
30?
36.
Yeah. Let me just say v squared outside.
Yeah. Now you have to state that which velocity it is, the final or the initial.
Isn't the 36 gonna be in the bracket and the 3 and the 35,000?
Yeah, they also have to be in brackets. Thanks for that reminder. So after that, we're gonna have.
I think do we like change, like, swap them, like take them over?
Yeah, I'm gonna sort them right now. So it's gonna be 36 VF
35. Oh, you're taking that one over.
36 VF squared. It's gonna be equal to 70,560 minus 35,280. You can see that.
Oh, it pulls. Wait. So,
This is positive, and when we're gonna take it to this other side, it's gonna become negative.
but doesn't the 70,000 become negative now because you're taking it to the left? I mean, to the right.
Like, it just depends on what you want to do. You can either take this one to this side, or you can take this one to this side and take this one to the other side.
Oh, okay.
Because like if I'm gonna take this 36 to this side, sorry, and take this 70,000 to this side, right? So the 36 is gonna be negative, and this is gonna subtract this. But now, since like we know that this is half of this, so one half is gonna remain. So it's gonna be negative
35,000. That's what I want
35,000.
to.
Nah, like I know, like I'm supposed to use a calculator and all, but this is like some quick maths instead of going through all that. So we're gonna have it like this, then divide it by negative 36. You see? Then now this negative 36 is out. And to take out this square,
root, you have to square root.
yeah. Then I'm not sure like if my I can't find my calculator next to me right now. So I just used my phone and I got 31.30 meters per second. Oh yeah, sorry. Let me just write in like proper grade 10 manner, you know. It's gonna be meters per second.
Yeah.
So that's how you write. That's how you guys write it, right?
Yeah.
Okay. So that's our answer for 5.4.
Just busy copying, like finishing the song quickly.
Yeah, just like from looking at it, like did you get lost somewhere?
Not actually. I'm actually familiar with this, but
Oh, okay, that's nice.
uh,
So like what's the next topic that you guys are gonna enter?
but I think this time we're gonna do a lot of chemistry.
Oh, oh. Unfortunately.
Yeah, only like the physics part.
Are you done copying?
Yeah, yeah, I'm done.
Okay, so like since now we have like 3 minutes, I don't think it's gonna take us that long to finish like 5.5. So I think if we finish like question 5, it's gonna be it's gonna be nice. Uh, I think this is a good amount of work just for like 1 hour.
Yeah.
But in the exam, you won't have 1 hour to do this. So you need to
Yeah.
be faster. So they say draw a graph for the potential energy versus kinetic energy of motion from the instant that the man jumps until he reaches the ground. So are you familiar with that graph?
The motion graph.
Sorry?
With which graph? The motion graph one.
Yeah, the motion graph. The potential energy and kinetic energy graph.
No, can you please show me about that? I'm not very familiar with it. Let me see.
So let me just write this here. And they say potential energy versus kinetic energy. Um, it's gonna be potential energy. Let's just put potential energy here. If I remember well, it's like X versus Y. So kinetic energy is gonna be here. So from the information we have, we know that as potential energy decreases, kinetic energy increases. Do you agree with me?
Yeah.
Sorry?
Yes.
Yeah, so like potential energy, it's gonna start like, this is from the positive X. Then this is the positive Y. So we know on our positive Y, that's where kinetic energy increases, and on our positive X, that's where potential energy increases. So it's gonna be something a bit like this. Can you understand it?
I'm a little bit
Because
confused.
because here